Here we have a SAT math question. Okay, let's go with the question. Bacteria are growing in a liquid growth medium. There were 300,000 cells per milliliter during an initial observation. The number of cells per milliliter doubles every 3 hours. How many cells per milliliter will there be 15 hours after the initial observation? Okay, actually it's a doubling concept. So we have to write a formula for doubling time. So the formula for doubling time is going to be y is equal to a times 2 to the power t over d. Okay, so let's understand the components of this formula. So here y is the number of cells per milliliter at time t hours. So for example, in this case, they ask us to find the number of cells per milliliter in 15 hours. So after 15 hours, to find the number of cells per milliliter, we have to plug in t is equal to 15 and we have to find the value of y. So the y stands for the number of cells per milliliter at time t hours. And A stands for the initial number of cells per milliliter. In this case, the value of A is 300,000 because the question says there were 300,000 cells per milliliter during an initial observation. So this is the initial value. So A is the initial value of Y. That means when t is equal to 0, the value we get for y is called the initial value. When I plug in t is equal to 0, so this part will completely become 0. 2 to the 0th power, this part will become 1. 1 times a is a. So the value of a in this case is 300,000. And 2, we use 2 as a growth factor because it's doubling every 3 hours. And here this d represents the doubling time. So here the number of cells per milliliter doubles every 3 hours. So 3 is the value we have for d. Okay, so t is the value, so for which we have to find the value of y. Since time in our question is given in hours, we have to assume both t and d in hours. Okay, so now let me plug in the initial value over here, that is for a. So that is 300,000. Then 2 to the power, so the value of dd is doubling time, it's 3. And we have to find the value of y 15 hours after the initial observation, that is the value of t over here is 15. Okay, so now we have to evaluate this. So 300,000 and 2 to the power, when I simplify this, and 3 goes into 3 1 times, 3 goes into 15 5 times, 2 to the 5th power. So y is equal to 300,000. So the evaluation of 2 to the 5th power is 32. So y is equal to 3 times 32 is 96, and we have 2 4 5 zeros. So 1 2 3 4 5. Okay, so 9,600,000. So after 15 hours of the initial observation, so the number of cells per milliliter is 9,600,000. So we find this one in option D. The correct answer for this question is option D.